So this video is going to show you how to use the unit circle and special triangles to sketch a sine and cosine graph. So what I've got here on the side is a unit circle with our coordinate points here, as well as the special triangle for the pi over 6, pi over 3, as well as a pi over 4. So we have the 1, 2, root 3, and the 1, 1, root 2. So real quickly, we're going to look at sine first, and then we'll come back to this screen in a second. We know that from the unit circle that the 0 angle is going to relate to the coordinate points here are going to be cos of 0 and sine of 0. So we might as well fill in some detail for the cosine graph at the same time. But the sine of 0 is going to be 0. And the cos of 0 is going to be 1 from the unit circle. We also know up here at pi over 2 that again cos of pi over 2 is going to be 0 and sine of pi over 2 is going to be 1 based on this coordinate point here. We can also see here at pi that we're going to get a -1 and 0. So at pi we're going to have -1 for cos and 0 for sine. And when we get to 3 pi over 2, we're going to again get a 0 for the cosine of that and a -1. If we go around the entire circle, we're going to end up exactly back here, and the repetition is going to carry forward from this point forward. If we are going to talk about tangent on the unit circle, tangent relates to the slope. So the slope of the line segment, or the terminal arm here, the slope is 0. The slope here at pi over 2 is undefined. So therefore, at pi over 2 is undefined. So we end up having an asymptote when we graph that. When we get back over to pi, over here, nice straight line, we get a 0. And again, when we end up down here, we get an asymptote. So undefined. And then we get a 0 again as it starts to repeat. So by using those pieces of information, we can start to sketch our sine, cosine, and our tangent graph, but it might be useful to have a little bit more information. So I put in the pi over 4 just so we can take a look at it. Pi over 6 and pi over 3 would be handy too, depending on which ratio we're looking at, just to get some more points. But we'll just do the pi over 4 ones real quickly just to get some data in our tables. So here, when we've got pi over 4, sine of pi over 4 and cos of pi over 4 are going to be the same thing. They're going to be 1 over root 2, or if you rationalize it, root 2 over 2. The nice one is tangent. Tangent becomes a nice positive 1. Now, as we go around sine, cosine through the different quadrants, we need to remember that we have our little acronyms here. So our sine is going to be positive in quadrant 1 and 2, so we will have a positive and a positive, whereas down here we're going to have a negative and a negative in quadrants 3 and 4. Cosine is going to go from positive to negative, negative, positive. So we're going to have positive 1 in here, negative, negative, positive. Now the ratio for the pi over 4 triangle is the same, so we have the exact same ratios, just an opposite sign. There we go. Now when we look at tangent, tangent's going to be 1 for all these ratios, but the difference again is sine. So it's going to be positive in quadrant 1, negative in quadrant 2, positive in tangent 3, negative in quadrant 4. So it's going to alternate back and forth, like so. So now I'm going to show you what the graphs look like and point out the points that are there. Now, granted, if we looked at the pi over 6 and got more detail, we would have other fractional amounts in between these ones here to give us a little bit better idea of the shape. But I will show you the graph and pinpoint those points for you. So as you can see here, I've already sketched the graph out, but I want to pinpoint the points for you and show the relationship. So this point here at 0 degrees, we said that our sine value, so this is our sine graph, I should probably write that up here for you, sine of x. At this point here, my value is actually 0. So this one here relates to that point there. when we go around to pi over 2, we end up here. Our sine value here is 1, so we end up here. As we go along the circle a bit more, there's our pi, we're back down to 0. And as we go around to the next one, we get down here to 2 pi. Oh, sorry, here. And then we get back to 2 pi. There we go. Now, if we do opposite rotations around, then you can see also if I go negative pi over 2, I'm going to end up down here at the green one again, at negative 1. As I come around to negative pi, I will end up here at the purple one. As I go around again, 3 pi over 2 negatively, I will end up here. And if I go around all the way around negatively, I will end up again here at the yellow spot of 0. Now, the relationship to this with your function of 1 over sine x, which we also know to be cosecant x, is that wherever there is a 0, 1 over 0 is going to become an asymptote. So if I was to sketch this on here, I will have asymptotes occurring wherever it crosses the x-axis at 0, just like so. We have shared points where if I have a 1 over 1, it's still going to equal 1. So these points here that are shared are actually at the top and the bottom. Same thing here, negative 1 over 1 is going to be still negative 1, other way. So you will have ultimately a graph that has these shared points here, and they will be trapped inside of their asymptotes, and giving you that sort of shape here. So from the sine graph, you can easily generate the cosecant graph, and just to separate them so you can see them on their own and what it looks like, that is the cosecant graph on its own with the asymptotes here at pi, 0, negative pi, 2 pi, etc. So using the same sort of logic for the cosine of graph, again, at 0, our cosine value is going to be 1. So that will relate to that point there. As we go around the circle, pi over 2, our cosine value is now 0, so our x-coordinate on the unit circle. As I go through again, over here at pi, we're going to rotate down, we're going to be at negative 1, we're negative 1 on the unit circle. And our very last one here, at 3 pi over 2, is going to be down here at the bottom, and we're going to be at 0 again. If we went around the whole circle once, we're at 2 pi, we're back where we started. Again, negative angle, if I'm going down, negative pi over 2, we're going to end up here at 0. If I do negative pi, I'm going to end up here at negative 1. If I go to negative 3 pi over 2, I'm going to end at 0 again. And if I go negative 2 pi, I will be back here at 1. Again, same idea for the reciprocal graph. So if I was to do 1 over cos of x, that is the same thing as secant of x. All my zeros become my asymptotes again. So I will have asymptotes through all of these values here. And if I was to look at the invariant points, the shared points, the ones and the negative ones, we'll see we have all these points here, and again, trapped between your asymptotes, so you will have this general shape, like so. And so a better view of that is like so, and again, the asymptotes no longer are at pi, negative pi, 0. Now they're at pi over 2, negative 3 pi over 2, negative pi over 2. So we have all of these asymptotes here. So a trickier graph is a tangent and the cotangent graph. So this one here is our tangent graph, and it's based on, again, the 0 points here for 0 slope and the asymptotes which are our undefined. So we have the negative pi over 2, and then the 3 pi over 2, and the negative 3 pi over 2 visible in this view. The key points here are really using the triangle of the 45, 45, 90, or the pi over 4, because the tangent's going to be 1 over 1. So those ones end up being really nice points here. So as you can see, there's pi over 4, there's 1, negative pi over 4, negative 1. 5 pi over 4, we'll get a nice 1, 3 pi over 4, negative 1. So these ones are quite important. And of course the zeros are important as well, as you can see. Now one thing that's slightly different between a sine graph and a cosine graph versus a tangent graph is that a sine graph has what's referred to as a period of 2 pi. That's a little squiggle that we saw with sine and cosine, the sinusoidal shape of it. This component happens over 2 pi and it repeats. So again, after another 2 pi, we'll get the exact same shape. So now we're at 4 pi. Whereas in this one, our period actually can go from 0 to pi. We have the same shape that repeats between pi over 2 and 3 pi over 2, if we want to go between the asymptotes. Or we can look at it between 0 and pi, and the same shape will then start repeating again. So tangent has a period of pi, whereas cosine and sine, they both have a period of 2 pi. So this is our graph here that we've sketched. In order to do the reciprocal graph, 1 over tangent, what happens is that anything that was a 0, because you're switching it, becomes an asymptote. And anything that was an asymptote becomes a 0, because you had a 1 over 0, which would have given you an asymptote, which will then become a 0 over 1, which now becomes a 0. So asymptotes and zeros will switch between this graph and the next graph, which is slightly confusing to identify if I draw them on top of each other. The ones are invariant points. They will remain the same between both graphs. So what we end up getting, and I'll try to do this in a different color, so I'll use red, the zeros will become asymptotes. So there will be my new asymptote. This is also an asymptote here. So that's one period I'm looking at. Invariant points become the same and asymptotes become zeros. So you end up getting a shape that's trapped here between the two and kind of does that. So there's one cycle of it. So if we were to overlay this multiple times, it gets really confusing looking at them both at the same time. So if we go move over here, you can see the shape, like I suggested, or I showcased, falls between your two asymptotes. Your 0 is where your asymptote used to be, your 1s are where they were before, and your zeros are now new asymptotes. There you go. So hopefully that helps to illustrate how the graphs are created by using the unit circle and some special triangles, and how their reciprocal graphs are drawn.